Hello, my friends. Today we're going to talk about scientific notation and how we convert between scientific notation and standard form. It's pretty good stuff because it's about how we write numbers when they're really, really big or really, really small. And a place where you might see it is in your science textbook when you're talking about things like small things like the size of an atom or really big things like the distance to the moon. These are all places where you might see scientific notation come into play. So if we need to convert from 7 3/10 times 10 to the third, which is written in scientific notation form, to standard form just means, hey, make it look standard, like we're used to seeing numbers look. Make it look kind of normal. So if we take a look, if we have 7 3/10, and what this 10 to the third means is multiply it by 10 3 times. And every time we multiply by 10, we know our place value system is based on 10, so really we're just moving our decimal point over one spot. When we multiply by 10 once, we would move it over and get 73. When we multiply by 10 again, we'd move it over and get 730, and when we multiply by 10 one more time, we'd end up with 7,300. And that's a pretty sweet answer. It kind of makes us light it up, I think. Ooh, pretty sweet. Let's look at another one, see if we can light it up again. If we have something like convert 3 800 times 10 to the negative fifth, and this time we have to put it into standard form. Now, the last one was a positive power of 10, which meant that we were going to be making a really big number, but this time, instead of making a really big number because it's a negative power of 10, it means we're going to be moving our decimal in the opposite direction. We're dividing by 10 rather than multiplying. It means our number is going to become super small. So this would be like the size of an atom kind of numbers that you'd see, really small ones. So it's to the fifth power, so that means we're going to move our decimal 5 times. So there's 1, 2, 3, 4, 5, and now I know that's my new spot for my decimal, and I can fill in the zeros in all of my movements. So I end up with 0.1, 2, 3, 4. There's my fifth number I moved around, and then I still keep my 0, 8 that I didn't have to move around at all. So here's my new number in standard form. Sure enough, that was pretty good, and I kind of was lighting it up again. Let's see that our lights come into play. Ooh, so fun. Okay, here we go. Let's look at what if we want to move the other direction. So this time I have a really big number and I want to write it in scientific notation. So this would be in standard form, and now I want to write it in scientific notation. When I write it in scientific notation, I'm going to have a number, one digit. I like to think about it. This is going to be the digits 1 through 9, and then my decimal point, and then any other significant digits times 10 to some power. That's kind of my general form every time. So this time I think about moving my decimal over until I get so that I just have one digit between 1 and 10 in front of my decimal, and I can see, ooh, that's where my decimal point should be. It should be 5 3/10. I need the 3 because it's a significant, it's not just a 0 tacked onto the end. And then I can look at what power of 10 should this be. Well, I know it should be positive because this is a big old number. Big means you're going to have a positive exponent. And how many times do I have to move it? 1, 2, 3, 4, 5, 6. I have to move my decimal 6 times, so it's going to be to the 6th power. So in scientific notation, 5,300,000 is 5 3/10 times 10 to the 6th power. Pretty good stuff. And of course, we wouldn't want to miss out on the fact that that's lighting it up in the math world. Good work. Let's look at one other one. So this time I'm going to take a really small number, really small. And I'm going to do the same thing. I'm going to have a number between 1 and 9 out in front of my decimal point, point something, times 10 to some power. This time I can fill in right away. I know it's going to be a negative exponent because this number is less than 1. It's super tiny. And then I look at where would I have to put my decimal point so that I get that one digit in front. Ooh, there it is, right there. So I get 3 21/100. And then I can think about what negative power is it going to be. Well, how many spots do I have to move it around? I have to move it around 1, 2, 3, 4, 5 spots, so I get to the negative 5th power. So there we have it in scientific notation. Light it up. Ooh, ooh. All right, one other type of problem that we want to look at here. We want to look at, what if a calculator shows you something that looks like this? I know you've probably all seen it before, where you get something kind of funny looking that you're not sure. Actually, what that's doing is it's writing it in scientific notation. It's saying you have 8 and 8/10 times 10 to the 10th power. That's what that e to the 10 means. It's giving you what that exponent is on your power of 10. So if I want to write it in standard form, I would have to take my decimal, and I would have to move it over 10 spots. So I have 1, and then I'm going to have to move it 9 more spots, so I can start to learn that, hey, that means I'm going to have 9 zeros on here. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's my 10th spot. I can fill in my commas, and I can erase this part right here so it doesn't even show up anymore. Maybe. And there's my number in standard form. Really, you know, when you're dealing with numbers, the decimal points are always sitting back here when you deal with whole numbers. You just don't see it anymore, and that's exactly where we moved it. When we moved our 10 spots, we moved our decimal all the way to the end. Pretty sweet, that's scientific notation. I think that's where to lighten it up one more time. Woo! Pretty good stuff. Have an awesome day.